You flip a light switch and the room gets bright. You plug in your phone charger and somehow electricity flows into your battery. But what's actually happening with all that invisible energy stuff? Today, I'll explain volts, watts, and amps to you like you're 5 years old. And by the end, you'll understand the difference between these three electrical mysteries without your brain melting. Think of electricity like water flowing through pipes in your house. This isn't a perfect comparison, but it's close enough to help you understand what's going on. Just like water moves through pipes to get to your sink, electricity moves through wires to get to your devices. But instead of water, it's tiny invisible particles called electrons that are moving around. And these electrons are so small, you can't see them, even with the strongest magnifying glass in the world. Now, let's talk about volts first. Volts are like the pressure of water coming out of your garden hose. Imagine you have a water slide at a playground. If the slide is really tall and steep, the water rushes down super fast because gravity is pushing it hard. If the slide is short and not very steep, the water just kind of rolls down slowly. Voltage is like the height and steepness of that slide for electrons. High voltage means there's a really strong push, making the electrons want to zoom through the wire. Low voltage means that there's just a gentle nudge. The electricity that comes to your house has a voltage of about 120 volts in most places. That's like having a pretty tall water slide for electrons. It's enough push to make them move through your wires and power your stuff, but it's not so much that it's dangerous if you're careful. Well, it can still be dangerous, so don't go sticking forks in electrical outlets. But it's not like a super high voltage power line that you see up on those tall towers, which do have thousands and thousands of volts. Your phone doesn't need a big push to charge its battery, it just needs a small, steady push. Now, let's talk about amps, which is short for amperes. If volts are like the pressure or push of water, then amps are like how much water is actually flowing through the pipe. You could have really high water pressure, but if you're trying to push that water through a tiny straw, not much water is actually going to come out. Or you could have low pressure but a really wide pipe and lots of water flows through. Amps measure how many of those tiny invisible electrons are actually moving through the wire at any given moment. Most of the things in your house use different amount of amps. A small LED light bulb might only use about 0.1 amps. That's like having just a few electrons trickling through the wire. But a hairdryer might use 10 or 15 amps. That's like having a whole parade of electrons marching through the wire. Your microwave might use even more, like 20 amps. That's like having a stampede of electrons rushing through to make those invisible wiggling fingers we talked about before. The wires in your house are designed to handle a certain number of amps safely. That's why houses have circuit breakers or fuses. They're like safety valves that shut off the electricity if too many amps try to flow through all at once. Now, here's where it gets interesting. Watts are different from both volts and amps.